Hi everyone. In the last session, we discussed various types of loops like while, do while, and for. After that, we have seen the syntax of while and the remaining loops. And I said the main difference between while and do while is the place where you are going to test the condition. So in the while loop, we are testing the condition first. After that, we are executing the statements. And the statements within the while are executed as long as the condition is true. Whereas in the do while, first we are executing the statements. At the end, we are checking the condition. If the condition is false, the statements within the do while are not executed. But at least once the statements are executed in the do while without checking the condition. That is the drawback of the do while. Whereas in for, we are checking the condition first, then only we are executing the statements. So if you observe the syntax of these three statements, the syntax of the for is both, not only both, so initialization, condition, incrementation, and decrementation, everything is done in the same statement in a single line. Whereas in the do while, so we are initializing the variables at somewhere and we are testing the condition at some point and we are incrementing or decrementing at somewhere. So at three different places, we are doing the manipulation in do while as well as while, but this is not the case in for. And another important thing is, so do while is the exit controlled loop, whereas while and for are the entry controlled loops. So what do you mean by entry exit? If the condition is tested at the beginning, that is called entry controlled. If that condition is tested at the end, that is called exit controlled loops. And also we have written some of the programs using while, do while, and for. First, we have written the program using while, and we have changed the same program into while as well as the do while. So this is about the last class session. In the today's class, we are going to see some of the interview questions which were asked in the technical interviews. And also, if time permits, we will execute some more programs using while, do while, and for. So let us go to the interview questions. Some of the interview questions, right? Now you see this. If you observe this snippet or code here, okay, this we know, everybody know the program starts with hash include stdio.h. The execution starts from the main. The only thing, important thing to know is about printf. What is the output of this printf? We are printing the values percentage d, percentage d. There are four percentage d's. So what is the value of first percentage d? This indicates that we are going to print the decimal value. Decimal value means integer value. So decimal number system I'm talking about. So the decimal equivalent of 62 is 62. So the first percentage D prints 62. What about the second one? Second one is 062 indicates that octal number. We are printing this octal number in the form of percentage D, means we are printing this octal number in decimal. So how to convert this into decimal? Take the octal value 62. No need of taking 0 here. So what you do is you take 8 to the power of 0, 8 to the power of 1. Now how to get the result? 8 to the power of 0 into 2 plus 8 to the power of 1 into 6, that equals to 2 plus 48, 50. So first percentage D output is 62, second percentage D output is 50. We are having a new slash in, right, new line. So that's why the output we are going to get is first one is 62, second one is 50. After that, what is the output of third percentage D? If you see this completed and this is also completed, now third one, 0x indicates hexadecimal number. Take the number 62, which is a hexadecimal number, you convert into decimal, that is 16 to the power of 0. Why? Because the base for the hexadecimal number system is 16. 16 to the power of 1. So in this case, 16 to the power of 0 into 2 plus 16 to the power of 1 into 6. This is 2 plus 16, 6 are 96. So answer is 98. So the third percentage D gives the answer Here I'm writing line by line. 62 first one, next 50, third one is 98. After this last one, 0 capital X, 0 small x, 0 capital X, both are treated as hexadecimal numbers. For this also we are going to get same value 98. So the output of this code snippet is 62, 50, 98, 98. That's all. Now let us go to another code. You see this. What is the output of this? In this case, we are printing the decimal value, decimal number system of 62. The output we are getting 62, same. But if you observe the second one, we are using percentage O. That means octal number. So we are printing in octal of 62. 62 is the decimal number. This 62 also decimal number. All these are the decimal numbers. So we are printing the first decimal number in decimal, and but we are going to print the second decimal number in octal. How to print the second decimal number in octal? 62 you have to convert into octal. How to convert into octal? First percentage D output is 62, right? Second, in place of percentage O, what it is going to print is take the number 62 and you convert into octal. You divide with 8. 8 7 is 56. How much? The remainder is 6. Next, 8 0. We have 7 6. So the output of percentage O here is 76. Next, percentage X means hexadecimal value of whom the again 62. Hexadecimal value of 62, how much converts this decimal number into hexadecimal? Divide with 16. 16 2 ja 32. 16 4 ja 64. So 16 3 ja 48. 48. So here you are going to get 14. 314. 314 is written as 3 into E. 3 into E. E means 14. So third, in place of percentage X, the third output we are getting is 3E, small e. Now what about last 62? Last 62 I am taking. This is given in capital X, means same hexadecimal number, but instead of printing small e, the last output we are going to get 3 capital E. The output of this program is 62, 76, 3E and 3 capital E. This is the output of this program. Now we move to the next code snippet. You see this. If you observe this statement, we are using here the size of operator. We know that the size of operator gives the size of a particular data type or a variable. So in this case, we have declared the variable integer I. So we know that integer can take either 2 bytes or 4 bytes. It depends upon the machine, right? Some of the compilers takes 2 bytes. Some of the compiler takes 4 bytes. My compiler is going to take for integer 4 bytes. Okay. Now what you are going to expect by seeing this code is you are going to expect the output like this. Percentage D means you are printing the value size of I plus plus. So this is post increment. In the post increment, we are going to say like this size of I. I how much? So what is the data? What is the data type of I? Integer. So size of integer how much? You are going to expect that 4 bytes. 4 bytes. After that, I is incremented by 1. So in the next line, by using printf statement, you are printing I. That means you are going to expect the I value is 2. So the answer you are going to get, you are going to expect is 4 2. But this is not correct. So what is the output we are going to get is, we are going to get 4 and 1. Why 4 and 1? Please remember that in bracket after size of, we said that I plus plus. Whenever you perform some operation in size of operator, this operation will not be evaluated. Though you have done I plus plus, I value not incremented by 1. I value remains only 1. So that's why we are getting the output only 1. So integer takes 4 bytes and here I value is not incremented by 1. It gets only the previous value. So that's why the output is 4 1. So this is the output of this code. Next, we are moving to another statement. You see this. C the integer variable, and we have declared the float variables a equals to 3 and b equals to 5. Now we say that c equals to b. B how much? 5 percentage means modular division 2. Because a is 3, right? 5 modular division 3. And how to get the remainder? Divide 5 with 3. 3 1 ja 3. The remainder is 2. So you are expecting the output is 2. But why? Because you have declared C as integer. Now integer gives this modulo division gives the remainder, and you are saying that the output is 2. This is wrong. Why? Why? Because A is of type float and B is of type float. Please remember, while we discussed arithmetic operators, the arithmetic operators are plus, minus, multiplication, integer division, and modulo division. See here, this integer division or this division operator, multiplication operator, subtraction and addition, these are used for both integer values as well as real values. But the percentage symbol is used for only integers, modulo integer division. It is operated on only integers. But here you are applying this operator on B and A, where B is float and A is also float. So that's why it gives the error. The output of this code is error message you are going to get, not any output. So this is very, very important. So what I mean to say that modulo division is only done on integers, not on float values. That is very, very important. Now, if you observe this code snippet, so what is the output of this program? Okay, we are declaring the variable I. And as we seen the syntax in the last class, so this is initialization, and second one is the condition. Here we are performing updation or incrementation. So here what happens is uh, first I value becomes 1. Next we are testing the condition here. 1 is less than or equals to 10. Yes, the condition is true. When the condition is true, then the control flow wants to come inside the for loop. But if you observe here, we have semicolon. The semicolon is not going to enter the flow of control into the printf statement. This semicolon sends the control back to I++. Or I can say, so instead of writing the statement for I equals to 1, I is less than or equals to 10, I++, just I'm removing semicolon here. If you put semicolon, the same thing can be written like this. For I equals to, I'm removing semicolon. Here I'm writing opening brace and closing brace empty. After this, I'm writing the statement printf percentage d slash n double quotes close comma I. Just I'm writing in place of for this for and removing semicolon and opening brace and closing. This is equivalent to only this for statement. Okay. Now, if you explain this code, then it is very easy. So I equals to 1. Okay, 1 is less than or equal to 10. Yes, the condition is true. Then go to this empty body. Nothing will happen. Go to I plus plus. I value becomes 2. 2 is less than or equals to 10. Yes, again go to empty body. Nothing is there. Like that, it is repeated. Nothing is printed. Finally, I value becomes 11. 11 is less than or equals to 10. No, condition is false. When the condition is false, this empty body is not executed, and finally the control is passed to the printf statement, and here we are going to get the output as 11. So now we will see another code snippet. If you observe this, so we are taking I equals to 1. Here I am writing I values. I value is 1. While I plus plus, this is post increment. First I value assigned to 1. 1 is less than or equals to 12. Yes, the condition is true. Okay, after that I value becomes 2, right? Now 2 is assigned here. 2 is tested with 12. 2 is less than or equal to 12. Yes, the condition is true. Now, next I value becomes 4. Next I value 3 is assigned here. 3 is less than or equal to 12. Yes, the condition is true. Next 4 is assigned. Next 5 is assigned. Next 7 and so on. Finally 12. 12 is assigned. 12 is assigned and the value becomes 13. Next 13 is assigned, the value becomes 14. But after becoming 13, 13 is less than or equals to 12. No, the condition is false. So when the condition is false, it breaks the semicolon and it goes to printf statement. It is going to print the value. But at the time of printing, the value of I is 14. So the output of this program is 14. I think understand what I'm doing. If you write plus plus I, you are going to get only 13. In place of I plus plus in while loop, if you write plus plus I, you are going to get only 13. See, we are comparing this I value 13 with 12. In this case, the condition becomes false. But after some time, I value gets incremented by 1. Why? Because it is post increment, right? So the final value of I becomes here 14. So the output of this program is 14. Now go to another program. You see here, this is very important program. So here, I value is 8. I value is 8. Here I am taking I value 8. First minus minus I. Pre-incrementation means I becomes 7. This is initialization and this is condition. This is incrementation or decrementation. So first, this is pre-decrement, right? First I value gets decremented by 1. So I value becomes 7. After that, go to the condition. So in the condition again we are saying minus minus I, that is 6. So here we are getting 6. So as per the syntax of our loop, first initialization, condition. In the place of condition we are getting 6. Very important thing I want to explain here is when the condition value is 0, you know its value is false. When the condition equivalent value is 1, that means true. Not only 1, you can take 2, 3, any value that becomes true. Not only positive values, you can also take the negative values. For this also the condition becomes true. Very important thing you should know is non-zero. Any non-zero is true. Only 0 is false. That is very important in each and every loop. Non-zero means true. 0 means false. This is the logic. Now here 6 we are getting. 6 means positive value, that is non-zero. So non-zero means the condition is true. When the condition is true, then we are going for the printf. Now it prints the value I value. How much? 6. We are getting the output 6. After printing 6, we are going for the decrementation I minus minus. So first I is assigned here. Next I value becomes 5. Now in this case, I'm taking I value. I value how much? So minus minus, condition is minus minus I. So I minus minus 5, already we have got 5. Again it is decremented by 1. Next we are going to get 4. 4 means again positive value, non-zero. The condition is true. Again printf statement is executed. Now we are getting 4. Next we are going for the I minus minus, means first we are taking 4. 4. After that we are checking the condition. Minus minus I means we are getting 3. So already I minus minus, first I value we are taking 4 and it is incremented, that means 3, and here it becomes 2. So finally it is going to print 2. 6, 4, 2. Now again I value is decremented by 1. I value how much? 2. 2 minus minus. First 2 is assigned, after that it is decremented by 1. So whenever we move to minus minus I, it becomes 0. So the value here we are getting is 0, means condition is false. Then this printf statement is not executed. The output of this program is 6, 4, 2. So we will execute the programs. Don't worry, but I'm explaining in theoretically. Next, this is the last code snippet. Here, what we are going to do is we are writing while one. While one means always the condition is true. Always the condition is true. When the condition is true, we are printing the statement hello. Hello will be displayed. Again, we are moving back. Again, hello will be displayed. So, hello will be displayed many times. This is infinite loop. Infinite loop. So, these are the some of the interview questions which are very, very important whenever you face the interview. With this, I'm going to close the class. Thank you for watching.